So our topic tonight is from the history of tunneling in New York City, the early days through to the East Side ASCE, presented by Brian Fulcher and William Cow. Brian is a principal at Delve Underground and based in Pasadena, California. He's also served as a tunnel and underground practice lead. He's the mechanical engineer from Queen's University in Kingston, Ontario, Canada, with minor in civil and mining engineering. Brian's 45-year career has included working as a contractor on the construction of hydroelectric and the mining site, steel concrete bridges, as well as numerous tunnels, tunneling underground projects, including 5 metro stations and tunnels. He's the member of the MOS, those are the several engineering licenses, and also one of the editors to the History of Tunneling in the United States book. So which will have a copy here. You know, ask Brian for some like editor prize and autograph afterwards. So William Cow is a senior structural engineer and has been in WSP for over 20 years. Mr. Cow has worked on the East Side ASCE project for over 12 years. He served as a structural design lead during the design phase of the main carbon station and as a senior supervising structural engineer during the construction phase. So now, without further ado, let's welcome Brian and William. All right, stage yours.
All right, thank you. Can I see the screen here as well, David? Can I see the screen or just only here?
Just only in there.
All right. Well, good evening. Most people are good afternoon. I'm very pleased to be here in New York. It's one of our most favorite places in the universe. We have a presentation tonight. It's about 40 minutes long. It's going to cover 140 years of tunneling in the New York City area. It does not cover New York State. It doesn't cover much in the boroughs. It doesn't cover a lot of things. But what it does do is give you a taste of technical achievements, achieving long-lasting infrastructure developments and facilities. And it also addresses really some of the technological changes that have evolved in New York City for tunneling that are actually tied to many geotechnical aspects, structural aspects, social aspects. So as I go through these slides, you're going to see various pieces of what you know, what you thought you'd like to know, and hopefully some new things, especially some images. I am a principal at Delve. Delve is based in San Francisco. We changed our name from several times, but we're also active in New York City. I'm not here recruiting. I'm just here to give a presentation on a subject that I find very passionate. So I got about 40 minutes. I'm going to keep moving. This presentation is divided generally roughly into 5 different segments, as you see on the screen. And I'm going to keep floating back and forth a few times between different decades and different types of construction and underground environment. And it will not always be tunnels. It'll be caverns. There's even one spot I've got an open cut, just to keep it interesting. But we're going to talk about early planning, conditions and other challenges faced by tunnel and underground construction, following the city's vision, adapting to what's really needed for infrastructure improvements, key design and construction achievements that are enduring. Probably the operative word here is enduring, because a lot of things we use today in the city were built 100 years ago. You probably came to work on some facility that's probably not less than 60 years old. And then some mid-century and modern design and construction projects. I'm just going to touch on them, but it's a broad subject, so I can't touch on everything in great detail. Most of our meetings, presentations always start off with a safety moment. When I found these pictures, didn't really have a technical use for them. I had a better use for them, and that's the safety moment for this presentation. The one on the right is one of my favorite. It's like everybody's going in the tunnel for an inspection. They're not dressed for work. They're in an open bucket of some description. It's about as haywire as it could be. We don't do this anymore. The one on the left side is just as bad for different reasons. It's an open, non-decked area, public environment. I don't know what that fellow's doing walking on the beam, but he's not doing it right. But anyway, all of our meetings, all of our engagements started with a safety moment. This should be no different. I'd like to give credit to several people right off the bat. Ian Cheney, thank you for the invitation a little while ago. And David and William, look forward to presenting with you. Anthony Del Vescovo is one of my colleagues from working on the 2nd Avenue. He contributed to this, and so did David Klug, Michael Roach, and Colin Lawrence, who are also co-authors and editors of this book, which is a 5-year 3.5 year volunteer effort. Some other organizations contributed one way or another to this presentation, need to be acknowledged. See them on the screen. But there's some others that get no attention whatsoever unless you're really digging. And that's the visionaries. The visionaries in the city years ago, actually decades and centuries ago, that had the idea of what they really wanted to see in this place. And you'll see various slides and various imagery that attest their capability and how they saw this city. Excuse me, I'm losing my voice. Okay, other people that need to be acknowledged are people that actually build things. The Sandhogs, the operating engineers, and so on. And finally, even though this is a large city that's, let's say, arguably office and residential, there's an enormous infrastructure here that is linked and that is contributory to actually building work, which is a little bit unusual. Cities call out to the moles, Sandhogs. Sandhogs actually produced something of a historical book, which is really quite interesting to read, written by people who are not authors, but it was quite interesting to have. So going on to the early planning, city had a vision of what it wanted to be. Mobility was a big deal, and you'll see some images here how congested the Lower East Side and the Lower Manhattan really was. Sanitation was challenged for sure. Growth and prosperity, this was going to be the center of the universe. And many people who live in New York, they know it is, even now. So quality of life was always a question. This was people lived downtown, they worked downtown, they lived in Harlem, lived in other parts of the boroughs, but they wanted to integrate city planning and transportation seamlessly. So there's a lot of joint use developments that came about. This image on the screen is actually very popular to me. It's Scientific American, but it's roughly 1905. That looks like an SEM tunnel or TBM maybe or something, but long before any of these were invented or conceived, but they had a vision of what they really wanted to have. Furthermore, we get into that image there, that's Second Avenue in 1934-ish. What's going on there, among many other things, oops, this thing backed up on me, is integrated systems of transportation, multiple levels, multiple modes, along with buildings and other commercial activities. But this is all part of the city planning. You see in the upper bullets there. And then sustaining. This city did not do something temporarily or with a short life cycle. As I said, many of the facilities we use today, even getting to work, going home, or in our daily life here, are decades old, and they will continue. They become older, but they're no less useful if maintained. Decongestion, this is another one of my favorite slides, or some others, or many others of this nature. There's no mechanized transport in that picture whatsoever. A lot of horses, sanitation's challenged, just getting from place to place. You know, how do you get to work? How do you go to school? How do you live in that type of environment? Well, the city was finding itself almost not imploding, but basically over congesting to the point it couldn't expand and it couldn't function. Then the transition to mechanized transport. This is a pre-car image. Utilities. I think if you dig up a street in many places in New York City, you're going to find the same image. I know we did in Second Avenue. We're digging up a few things by accident or deliberately, and we had to get through this type of utility environment. But no matter what you had to do, you wanted to have tunnels in rock and soil, and the subaqueous conditions were pretty challenging. The other problem with utilities, I'm just going to say, however, briefly, it does have something to do with tunnels. It has everything to do with tunnels. They're very difficult to manage. If you've been involved with planning major infrastructure projects, the utility relocation work in advance of underground is horrendous, long, difficult, uncertain, and costly. Quality of life. I love this image too because it's one of the few tunnels or few images that shows multiple levels of tunnels, mezzanines, subterranean galleries at Grand Central Terminal. After, I guess this, it would be the terminal, and you can see the Steinway Tunnel on the bottom. And William's going to talk about something that's still yet lower, 100 feet lower than Grand Central, roughly, say, the station, the tunnels. So pretty impressive. Now there's another piece of Grand Central that's not on here, and that's some of the utility rooms that are, to engineers, pretty captivating because they're very deep. Okay. So again, more joint use of space, commercial and personal and private development. Some of the conditions and challenges facing early tunneling projects. Oh shit, it's a screen here. I have to show the VLA map. does everybody know what the VLA map is?
Yep.
Everybody put their hand up. Thank you. Like this. The VLA map, first of all, it's a nice piece of artwork. It hangs in our home, at least a copy of it. We went to the map room at the public library, a daughter and myself, and they brought it out. They brought out the original, 4 pieces. Of course, we took it out of the plastic sheets and got our fingers all over it, but they're quite big, but it's there. Anyway, this is still in vogue today. This was used at 2nd Avenue for some of the planning, 2nd Avenue subway. And I imagine it's used other parts of the city for other similar planning, because the water courses, some of the geomorphology is still current, or it's current in a subsurface condition environment. This is a rather important 1870 set of images. Does everybody, please tell me everybody knows what pneumatic subway is in New York City. Good. Alfred Ely Beach. Tunnel designer and builder, editor-chief of Scientific American, entrepreneur. He financed this, excuse me, and he also built tunnel shields. Okay, he's a New Yorker. This is one of the early tunnels initiated on the across the Hudson. It failed, or at least it didn't go to completion. It was around the 1880s. There's a rather significant report by ASCE, and I'm going to keep referring to ASCE reports over time in this presentation, by a fellow named Burr. I have a copy of it at home. It's rather interesting. That's where these sketches come from. But to me, it's one of the early recognitions of the rock conditions, soft ground and rock conditions under the Hudson at that location. Okay. So in these 2 images, you see the shafts on the east and west side of the river, and then the cast iron initial liner and the final concrete liner for the rail tunnels. And these are relatively small. These took something like 25 years to build from beginning to end. Okay. Then we get into a rather significant job. I'm just going to touch on this. This in its own right is its own presentation. These are the Pensy tunnels, or the tunnels across Manhattan from New Jersey through across the Hudson. And this was a very major undertaking around the 1910, 1915 era. Again, extremely well chronicled, illustrated in ASCE publications. This is just a piece of one side of it, and the reason I flagged the portion of the image on the bottom is because that's face mapping. That's the early stage of somebody actually looking at the geological conditions in the tunnel as it's being mined and lined. In that particular section, it would have been rock tunnel, so they could actually see the rock. Okay. And the methods of construction included top heading and bench. These are very primitive drills and methods of ground support by our standards today, but in mining operations, small mining, unlike tunneling, they're actually still used. There's some other things that are not used, but nonetheless, some of this is still being used. Soft ground tunnel shields. Remember, soft ground tunnel and shields is really an embedded element of construction of tunnels in New York City. TBMs, I will touch on this later, did not come into the city till the last few decades. Again, one of the more notable tunnels, this is the first subaqueous tunnel in North America. Goes from, let's say, the Upper East Side to Long Island City. It is a gas tunnel. It was a privately financed job. It was mixed face, rock tunnel, and soft ground. And then the cast iron liners are shown here. And these images actually come from about a 40-page report written by a guy who was in charge of the Hudson River tunnels, went over to the east side and did work on those tunnels for a few years. This tunnel, as long as it is built in about 2 years. And as far as I'm aware, it's still in service today. Okay, that's 1892. Okay, switching a bit, same era, going over to transportation. This is one of the earliest maps I've been able to find of Manhattan. Again, I'm kind of excluding the boroughs because it's a broader subject and an important one. The early transportation corridors using rail, and some of the lines on here indicate surface rail. Others are to be built underground in one way or another. And another early map, again, pre-construction, the red lines here would indicate basically tunnel work. This would have been the Broadway line with a connection into the Bronx. Blue, for the most part, would have been elevated. And over the decades that followed, this is around 1905. So you get up to about 1940, 50, 60, almost all of those blue lines, elevateds, are torn down. And to some extent, replaced with an underground facility. I won't go into detail, but let's say 2nd Avenue, which we know has a subway, it used to be an elevated. 3rd Avenue used to be an elevated. Okay, so things are not always that easy. There's a pretty good image if you look at it in various pieces where it was like, we're going to build a subway. It's 1905. We don't have environmental controls. We don't really pay too much attention to settlement, building deformations or anything. So this image is about the calamity of building something in an open cut. A lot of this is done with pick and shovel. You do not see heavy equipment. You do not see a lot of things in this picture. There's some other ones like it where the rakers are up against the building because it's coming down on the excavation, which is not a good sign. But some of the things that we hold dear today is dig underground, almost sight unseen. This is in the middle of the whole street. Okay. Same with this. This is a utility relocation, but this particular image could also migrate into a open cut tunnel. What's interesting here, just a wee little detail. Does anybody see the cable zip line, high line in the picture? That little A-frame? They didn't have a crane. That's how they move material around. Be it heavy timbers or tunnel spoil or any kind of excavation at this cableway in the middle of the city. Okay, disruptions to public. I keep coming back to public safety, disruptions, quality of life, and that type of thing. This is a theme that is with us now. It's much less than it was decades ago, but at least in this picture, they've got some handrails and a few other things that attend to public safety. If I have time, I'll tell you a little bit about some environmental controls in 1912 that affected Second Avenue subway. Time works. I don't know if it will yet. But. Okay, moving on. We've got other subways being planned. They're in competition. We've got, I never get this right, IRT and the BMT competing with each other. Both have major underground operations, be it stations, tunnels. They take up a lot of real estate. They have power plants, cable tunnels, a lot of facilities that run these operations. Eventually they are merged. But I always like to give a picture of what can be done. And if you look at this one, this is City Hall Station. I personally have not been to this one. Has anybody here had the tour? Is it as grand as what it looks like here, or better?
No.
No?
Subway conductor. I've been there several times. But
it looks wonderful, and it is what it is. It's decommissioned, but this is why when we talk to the public, we can build these things. We can design, build, maintain. Tunnels under Central Park. What's interesting about these images, it really should perhaps talk about the right-hand side. That's ground support as much as it is at the time. But then you look at the left side, the rock portion. It's not a single rock bolt, no shotcrete, no ribs, nothing. And there's a ton of overbreak. That was a bad word at Second Avenue. We had a lot of it. But here you can see the liner, you can see the overbreak volumes outside the liner. But this is work in progress, and we're still doing the same thing with the same forms today. At least they haven't changed too much. First transit tunnel under the East River, shown in this image. Major problem, major headache to get across some of the soft ground, compressed air, shield, cast iron segments. But this is, again, using the technology and the hardware that was used a decade earlier under the Hudson. And I believe this tunnel is still in use today. Okay, now we're going to switch gears just a wee bit. We're going into Quezon Tunnel building. This image, again, from, I want to say ENR, or a journal of that nature. There are several journals in the late 1800s, early 1900s that basically illustrated, chronicled almost every major civil engineering job in New York. ENR, Engineering News was one, Collier's was another, certainly Scientific American, and there's several others that you would not normally remember, but these images are available online. This is Harlem River Tunnel. I think it's line 2. Here's line 345 with an image of a quad tunnel. And rarely do you see that even today, a quad tunnel. Now, maybe precast concrete, something of that nature in Europe or South America, but we don't see that very often today. Okay. Remember, this is in the day of pre-diesel engine, pre-big crane, pre-pontoon floats, and they're doing this around 1915. More of the same. Here's the drawing from one of the historical researches I did, some of the dredges that were used. And again, this is back in the day when a lot of things we think almost nothing of for marine work and construction work, that's what they did. And this crossing was only like 600 feet. It wasn't particularly long because they had approaches in a water environment. And again, much the same. We're trying to sink a four barrel sunken tube. I call it sunken tube. Other people call it immersed tube. They're the same. And before I leave that, I really want to say that the patent for this and the original tunnels on this are American. First sunken tube is Detroit in the world. This one I just showed you a second. Okay. Okay, so if I get a drink here, we'll go on to means and methods. Just I'm going to touch on this. I know this is a geotechnical crowd or structural crowd. Talking a little bit about means and methods is probably healthy, because I'm not sure who's ahead. That is the mechanics ahead of the dirt and rock, or is the rock just getting used to it, you know? So this is a typical tunnel shield. This is something that Alfred Eli Beach would have designed, or his counterparts previously, Barton from England, Greathead from England. They're all very, very similar, and they're just a shield. They don't have grouting, they don't have drills, they don't have a cutter head, they don't have much power. The survey systems in here are candles and mirrors. I can't begin to explain it to this audience how they work, but let's just say it's a set of mirrors, and there is an image, another historical image that has the grid, how it worked, and it's also the same image that shows donkeys in the tunnel hauling the muck out. But the early tunnels, water, North Tunnel, North River, which is Hudson, East River gas line and other tunnels, this is the type of equipment they would have used. So breasting, you can see the gates on the far right side, but everything is pick and shovel after that. Okay. Great image, Holland Tunnel, north, I guess it's the North Drive, the shields came together. Now I can't tell exactly, but the top of that picture is probably 3, maybe 4 inches apart, these shields came together. And then how would you survey it? We have a hard enough time surveying optically or electronically today. This particular, I'm tempted to pass this around, I probably won't get it back. This is a 1925 tray. That image is here. Okay, this comes Hudson, I'll just read it. Hudson River Vehicle Tunnel commemorative tray on the occasion of the North Shields coming together. So what it looks like, not take a picture soon enough, there you have it. This tunnel went in service in 1927, it's still in use today. Okay, so what we got now? Now we move on to other tunnels, similar configuration. About 10 years later, this equipment was used for the Lincoln Tunnel first tube. And it didn't really change between the first, second, and third tube, because they're similar ground, similar machines, but pre-TBM. TBM as we know it, as the mobile rotating cutter head. So you got the Holland Tunnel, Lincoln Tunnel, and eventually you're going to see the Queens Midtown Tunnel. But they still didn't have things that were perfected on pre-excavation grout, which we love today because it changes the ground characteristics, so our mechanical excavating devices and other facilities work better. They didn't pay much attention to fire life safety systems because there's lots of people running around those tunnels that don't look like they belong there. And hyperbaric pressures, a lot of this stuff wasn't really well understood back in the day. Today, with more science, it is far improved. Okay, environmental, I need to touch on this briefly. Some time ago, a bunch of us put together a very large paper on tunnel muck haul, treatment, spoil. I was just about blown away when I realized through some research that Governor's Island is really the muck that came from Lexington Avenue subway in 1915. So, which sort of explains why it doesn't have trees in some extent, but apparently somehow the muck made it from Lexington Avenue across the water on a barge and landed in the island. So here we have it. What they did about water control, water discharge treatment, don't know. I know what we do today, and it's a big part of the expense and science that goes into these jobs. Another thing, I mentioned hyperbaric a minute ago. Back in the day, almost every soft ground tunnel in the city was approached as a compressed air tunnel. Today, well, at least up to a couple decades ago, that was the norm. Now today with earth pressure balance, but we still use compressed air in airlocks to do servicing of earth pressure balance equipment. That's the badge that people wore if they looked like they were in tough shape, they had the bends or whatever, and they were away from the tunnel. It's like a medical alert badge, okay? But we have far better controls on airlocks, medical locks, people training than was present decades ago. It's commonplace now, but we do not normally use compressed air tunneling. We use compressed air airlocks to get ahead of the cutter head for maintenance and so on. Design and construction, one of my most favorite images too. That's a postcard. I found it, I bought it, and it's in the book. We had to go get rights to use it. But I don't know, perhaps there's a person in this room could tell me how to survey those knitted tunnels, nested intertwined tunnel. I don't even begin to comprehend how we could do double stack quad tunnels intertwined like that back in the 1905 era. Okay. And back in 1905, there were environmental controls, just don't talk about them. There was design build and there was design build finance. So if you wanted to invest in a tunnel, you bought common stock. There's the tunnel on the stock certificate. I don't know if it made you money, but you could buy in. Okay. Then this is another rendering of the other tunnels under the Hudson, other rail tunnels. This would be the Pennsylvania tunnels. And again, they're built in about the same era. They're finished in the same era. Some other tunnels that are still, I ride the 456 line when I was here for years and never really paid much attention to them, but you know, they're double stacked. So are the stations. Some of them are side by side, as we saw going under the Harlem River, some are vertical, okay? And the map, which I'm sure everybody's seen 100 times with the red boxes around it, are trying to highlight almost every subway line in that map is a tunnel. There's no elevated, no at grade. What's my time?
10 minutes. 10.
Oh. Okay, moving on. More tunnels. Again, the subway tunnels are a big part of the early part of the 1900s. Almost nothing in the middle part except in the 1940s. Tunnels under 6th Street, but they're all cast iron. There's no fabricated steel for linings. There's no precast concrete. And there's reasons why materials were chosen, largely to do with economics, but had something to do with structural, or the infrastructure in the area would not support, say, fabricated steel, where in the case of BART, San Francisco, Kaiser, fabricated steel was the answer. Here, in this environment, all roads seem to point to cast iron. So nothing really changed for literally decades. Okay? Then I'm just going to touch on very briefly on some road tunnels. I've talked a little bit about these, but a few more slides that are important. Holland Tunnel, first vehicle tunnel under the Hudson. I'm sure you all know about it, drive through it, stay away from it from time to time because of the traffic. Very notable from a geotechnical perspective, ran into rock, had to do some blasting in front of the soft ground shields. Very notable from a ventilation and gas extraction point of view. Some of the people who were involved with this tunnel came from other tunnels. Ollie Singstad went on to other tunnels, became very well known in the tunnel industry in North America, largely because of what they learned and what they achieved here. That was one of the original concept drawings. This again, I like these things because this is the original thought process of ventilation. They're hauling coal, little cars and trucks. It gives you a sense of scale. Now you do that today, it's probably a little short of a shoulder or a pedestrian walkway or fire life safety systems, because they would have been largely tunneled to make them all fit. And over here, again, more postcards. Back in the day, oddly enough, you could actually buy postcards of industrial facilities. So that's what these are. So that's what it looked like more or less an opening day. Then you get something even more intriguing. Has anybody seen this image before? Okay, Illustrated London News back in the day. I'd seen that over and over again. It shows up in the book. I didn't pay particular attention to it. I don't know why, but because we're writing another book on another subject to do with precast segments, this showed up from the Sun. So I did some more research. Sun is the chief editor, is the brother, sister, brother-in-law, whatever, of Alfred Eli Beach. So they're all connected. Now I'm starting to realize, I'm going to walk over here. You probably can't see it. That's 42-foot diameter shield, and then probably the outer cutter diameter, maybe 6 inches to a foot bigger. That's 42 feet in 1919. Pre-TVM, pre a lot of things. Not to mention the horsepower and the hydraulics to run it. But then you realize, I'm starting to figure what this is. That's not cast iron. Precast. And there's the patent drawing. I promised one to you. That's a piece of the patent drawing from a fellow named John Francis O'Rourke. Now, what's important about him, he's got about 9 patents. He's a compressed air guy, Poughkeepsie Bridge, a lot of tunnels. First patent, precast segment used in a tunnel was in Montreal, was his design. It's still in use today. Okay, so didn't get built. This proposal was made by O'Rourke and Goethals. Goethals is Goethals Bridge, Panama Canal, same guy. didn't get built. It got built in favor of a twin tube. Same era, 10 years later, almost the same scheme as Lincoln Tunnel first tube. Again, this is interesting because it's getting more and more mechanized. We're using cast iron segments. We've got a more elaborate airlock. We've got a lot more goings on inside these tunnels. We've gotten rid of the forces to draw the muck train out and so on. It's virtually the same view with more cross sections. So you can see the enormity of the weldment. And this was prefabricated, lowered in place, and off it went. There would be two of them for each tube. Moving on to the Queens Midtown Tunnel. This is also done a bit later, actually, in the 1930, 35, 40 era. Again, soft ground, mixed face, and rock. Drill and shoot and soft ground in the same tunnel, plus the approaches. There's some images of the work in progress. This is an interesting tunnel on by itself because there's very little chronicled on in technical press or ASCE or any of the societies. This is the Brooklyn Battery Tunnel. It's very significant because it's the longest tunnel at the time underwater. But because it was built post-war, I suspect there was a little bit of secrecy. There's more written about this tunnel in scientific, popular science and popular mechanics than anywhere else, or Look magazine. But again, still in use today. I think it was commissioned around 1950. Now, I'm not going to say much about water tunnels. I'm sure everybody knows a lot about water tunnels. It deserves its own lecture because they are very significant. This is just a map of, for instance, the local tunnels around Manhattan, some of the vintage drawings or photographs, but that's what we used to do, unmechanized. So it was mechanized from the point of view of having an air drill, but it was not mechanized from the point of view of hydraulics and other equipment that we know today. We wouldn't normally do that type of tunnel today without major TBMs. Okay, mid-century. Now, William's going to pick up on this. He's going to talk a lot more about East Side Access, but this image is important because it's one of the few that shows the vision of a 4-track subway. You got one system on top, here's Amtrak, transit on top, and Amtrak below. But this came about in the image is from about 1960, but the concept is 1940. That's how long ago this has been around and fermenting and distilling. So, and it was eventually built in the late 60s and early 70s, but it was like the tunnel to nowhere. At least the top, I'll never get this right. The top two tunnel carriageways were used, the lower ones were not, for the longest time until Second Avenue Subway was commissioned. Okay? And that was in 2017. So what we've got here is, now we're going to talk briefly about Second Avenue Subway, which is one of my pride and joys. I worked for the contractor. We built 72nd Street Station and tunnels. Initial planning in 1929, but the documents go back to 1922. So 100 years ago, people were thinking about putting on underground subway up Second Avenue and getting rid of the L. Okay, they had a vision. And part of this is mobility, as I keep saying, part of it is just growth, commercial development, and so on. But about 2 months later, Great Depression kicked in. Okay, so we restart in the 1940s and 50s. There's, get my image right. This document, this drawing is edited in 1950. There's a very important connection of Second Avenue Subway with 63rd Street Tunnel, which is probably a dream at the time in around 1950. But then in 1972, it sort of got a restart. Here are the people on the ceremonial pick and shovel, picture taking opportunity. Anybody recognize people in the picture?
Sure.
Who?
I think that's Mayor Lindsay.
Who?
Mayor Lindsay. Or
Who's the guy? Who's the guy in the middle?
Rockefeller, yeah.
Well, that's the one I recognize, but okay. And then actually, some of the work got built in the high 90s. Some of the
on the
Yeah, that was, Mayor Lindsay, yeah.
okay, and some of the work got built in the high 90s and got to call it mothballed or abandoned. Later, it got restarted in around 2007. This is the hoopla to say, oh yeah, we're on it again. These gentlemen seem to be pretty happy about it. And then the concept was different. It was different because it would have high arch, a lot of voluminous excavation, stations that you had lots of artwork, which I'm not showing pictures of. It's a geotechnical conference, but the artwork in these stations is fantastic. And it makes you feel like you want to ride the train. So that's 72nd Street. There's many other images much like that for 86th Street and 96th Street. So as you probably know, there's several phases. We finished phase 1, phase 2, 3, 4 are in the future. Remember, the concept started in 1929, so future is quite long. And then say one more thing. This is our job. And people in this neighborhood were I would say anti, but not in favor of, not in my backyard issues would creep in, disruptions to their lifestyle. They didn't like blasting. The windows would shake. It was kind of annoying. And then you go to community meetings and people stand up, pound the table and say, when will it be done? I want my grandkids to ride the subway. Come on, move it, let's go. But there was also a bit of a revolt over dust. And I bring this up because this was current. This is something we had to deal with. And then years past, decades past, it didn't come up. Same with blast vibrations and so on. So conclusions and a little bit of a summary. This is much like I started. Why do we have all this? It's enduring infrastructure, quality of life, mobility, commerce, growth, prosperity, and integration. So we don't have to spend a lot of time wandering around on transportation systems, other systems, utility systems that work some of the time, but it's all part of better use of underground space. And then use of technologies. The reason I had to find a home for this small horse, this is the way things were before they were mechanized. And this is not unusual. This is mining. This is tunneling. This is New York City, okay, back in the day. This is 100 years ago. And what's happened in New York City, to some extent, it has embraced tunnel boring machines. They've been around since the 63rd Street Tunnel was first excavated, the very first phase of it. This is the Queensport, we call it Queensport Tunnel. There's 2 TBMs in the Sunnyside Yard area. And since then, there's been TBMs on 2nd Avenue and the Water Tunnel. But it's been a long, slow process. And with that, I think I'm out of time. Thank you.
Okay. Thank you, Brian. Before I begin, I just want to say it's an honor to be here. And I'm Brian Fulcher. It's an honor to be presenting this with you. So the East Side Axis, I'll be talking about the East Side Axis today, and East Side Axis spans from Queens all the way down to Manhattan, and every foot of East Side Axis has an engineering story of its own. But today I'll be focusing on the terminal station, which is the main cabin station, and I'll be talking about the highlights of it and more or less the structural design and aspects of it. So Queens is off this map, but the Manhattan alignment at the very least starts from, as Brian mentioned, the 63rd Street Tunnel. Okay, and it goes west, veers down Avenue, and then it goes underneath the M&R train shed, where the Grand Central Terminal is. It also, here's a rendering of it. The center portion, those are the 2 cabin stations. And it's connected by cross passages, and it connects all the way up to the concourse via these escalator shafts. I should say, where it says future concourse, the future is here. The concourse is there now if you go and visit it. Here's the longitudinal view, and the main cabin station is underneath the M&R train shed, and it's underneath the Helmsley building and the MetLife building. And there on your far left, that's the historic landmark, the Grand Central Terminal. Here's a cross section of the terminal station. They're twin cabins, 4 platforms, and 8 tracks each, connected by the cross passage and connected via these escalator shafts that leads you to the concourse. Now you can see from this photo here, the M&R train shed, the far left of the lower level, has been removed to make way for this concourse. So as Brian mentioned, the 63rd Street Tunnel, it was envisioned since the 40s. It was sunken in the 70s or so, and the 2 upper tracks were for the subways, whereas the 2 lowest was for this Long Island Railroad project. That pair of tunnels make its way into Manhattan. It bifurcates into 2 pairs, which further then bifurcates into now 4 pair, which makes a bore of the main cabin station. That's the 8 bores that you see here. So excavation starts with the bore, and then there's the upper portion or the cavern arch, if you will, gets enlarged, and excavation begins with a top-down approach. Here's the cavern arch that's been excavated, and you'll see from the scale is a bit off here, but the cover between the arch to the M&R train shed was about 15, 20 feet or so. Okay, so to supplement some of the ground improvement and the rock support to hold up that M&R train shed, we built what we call the separated arch, which essentially the final lining of the cavern starts almost as a top-down approach. The roof was built first. This is not unique. Taking advantage of the Manhattan bedrock, the separated arch was able to socket and seat onto the rock ledge, which then support the rock and the M&R train shed above. From there, they benched down for the remaining excavation. So this is where things get interesting. So the main cavern station traditionally was always envisioned as a cast-in-place design. And so for many benefits, precast was becoming, it was getting more and more attractive, and it was becoming a large consideration for the East Side Access project. Okay. Now I must say, when during the design phase, this was around 2008 or so, myself, my team did a lot of research on underground precast stations, and there were not many at all. I had a quick chat with Brian Fulcher right prior to this presentation, and he did share with me there were a few, which I'm going to look into. But when I asked about the years, it was around late 90s, early 2000s. So I'm comfortable to say, although it may not be the first precast underground station, it may be one of the first few. So there were not many examples for us to go by. Sure, you have precast segmental liners. That's quite ubiquitous. You have precast raised wall shafts, ventilation shafts. But as far as underground, there's nothing else. And then you have precast superstructures, buildings, parking lots, what have you. So we did do a lot of research into all those components to have a better understanding of connections, of the benefits of precast, etc. So what are the benefits? There are many benefits to precast. Particular to our program at that time, we need to get an early begin. So precast, you can start creating these members ahead of schedule and off-site. Okay, this reduces schedule risk. This takes things off of the critical path. You limit on-site operations, underground, limited space, logistics. Okay, reduce construction schedule, repetitive shapes. You build it once and you can build it a number of times. You got yourself a very efficient design. The quality of finish, surely casting something out in site can be as high quality as doing something in a controlled plant. With quality comes durability, and if done right, you can integrate this with an architectural finish, which was taken advantage of on this project. Pre-planned connections. Oftentimes out in the field, things are not really where they're at, but with precast, you can really lock it in, and all the connections are the same. Even the installation process of it becomes routine. So all these are great benefits for precast. Precasting in general, but for this program, precasting the main cavern station. So this is an early, effort on what to precast and what shall be cast in place. This has changed during the evolution of the design. But what you see here in blue was cast in place. What you see here in green would be precast. And the objective really was to try to make everything as green as possible. Try to make everything as precast as possible. But you always come across how to connect them. You always come across, there's still a waterproof structure, how to integrate the structure with the waterproofing, etc. So there is some cast in place as well. Other things to consider, you have to really define the parameters at the get-go. When it comes to precast, you have to consider the weight of it. With that way, it defines the geometry, defines your final shape. You have to consider that these things are going to be handled, lifted, transported, erected. And so we at least for design purposes, set a parameter of 25 tons. And then we had to also consider some members of this might be too large where you have to might break it up. Okay? The more things you break up, the more things you got to consider how to connect it. And you got to consider connections to be quite simple, fast, easy, and it'll create what we call an immediate working platform. So as you install the beams, so as you install the decks, you have yourself a working platform. So this is just an overlay of all the upper level, mezzanine level, lower level. And what we're looking for here is how to even start considering for precast. You start studying your structure, and you start looking for repeatability. And you'll notice here that, you study the structure such that you pick a limit where it starts repeating again. And we zoom into what we have here. This boxed out area repeats itself 4 times. Naturally, for the layout of the Grand Central Terminal, everything revolves around the nodes, the streets, which are namely 45th, 46th, 47th, 48th Street. You zoom in onto this, and then you start studying each beam. Now, when it was cast in place, you can vary the geometry a bit. Oftentimes, you try to optimize it, minimize it for a number of different types of beams. But for precast, you do that even more so. Okay. This is a 3-dimensional rendering, but it shows the 3 different modules, as we call it during design, of one particular area that seems to repeat itself throughout the length of the cavity. This is a very early rendition of color coding like-kind beams, trying to group things together. And we do this several times over a couple of trial and errors until, over the evolution of this exercise, you start fine-tuning the number of different types of beams. You also have to start thinking about how to break up the beams. Do you do a double T-beam? Do you do a single T-beam? Or do you break the T-beam all together into a beam and that type of configuration? Now, as I mentioned, the more you break it up, the more you have to think about how to connect it together. There were some large elements, as I mentioned, that exceeded the parameters that we set forth at the beginning, size and shape, and weight. And so you have to break that apart too. There were cases where we had what we called a multi-beam, where it was a large beam that carried the escalators, if you will, where we had to break that apart. Again, trying to keep within that 25-ton weight limit. All said and done, after the exercise, you have something like this, where you envision how things all come together. The more you break things up, you're actually reducing its, stiffness modulus, and so you have to now consider, camber and deflection. That's in place, you wouldn't have to need to worry about this. Connection details. We took great care, we took great detail in our exercise to really draw out all the details when it comes to the geometry of your precast members, such that you eliminate the need for formwork, on-site formwork. That's where construction time could really be greatly saved if you just detailed your precast element so that you don't need formwork. You place the deck down, everything is closed off, all the surface areas are closed off, such that when you do the closure pour, just go ahead without any formwork. We came up with some of these, what we call the hammerhead details, that kind of wraps around at the edge. The lower right, what we call a boot detail, where it kind of closes the bottom surface of it. Connections, quick, simple. Some of our connections for our precast platforms were nothing more than just double-headed bars through dowel sleeves. Quick and simple. So, all said and done, you try to come up with as little different types as possible to be used as many times as possible. And the two that I just want to highlight here is, say, the mezzanine and the upper level beams. Okay, there are 24 what we categorize as 24 different types that can be used 338 times. That's more than 10-fold. Whereas the upper level beams, 15 different types, used over 520 times. So what is that, 30 times repeatability, if you will. Once we got this out to a contractor, they submitted their study of it, and this is a precast. It's formula with our precaster, and they determined that they can get away with 8 different types of forms that'll build the entire 835 number of beams. So they have even 100 time folds. Okay. Again, benefits of precast. That said, I'm going to hop into the some of the photos, and I'll zip right through this. Here are the early days of excavation. As I mentioned before, the overhead arch was enlarged, excavated first. You can see how the top portion there, it's shaped out, the rock ledges are shaped out for that overhead, what we call the separate arch structure, which is the overhead structure of the final lining of the structure. It's waterproofed. It is then cast. You can see that overhead separate arch liner. In the background there, those are the boards that started the excavation of this main cavern. So from here, we start, from here, you now know your overhead rock is supported. The M&R train shed station above is well supported, and you can start benching down. Bench one side, bench the other side, bench the middle, and here you have the fully excavated cavern. You can still see the raw rock on either side. The inlet here, a mud slab was poured. Water that's collected, that's just an excavated pit that filled up with water. Makes for a seemingly picturesque picture. Here is one of the steel forms that the precast plant built. We had the opportunity to go and during the fabrication to take a look at the process. This is one of those multi-beams being mocked up, okay, being put together. This multi-beam here is a series of 4 beams put together, post-tensioned. And you can see here the grout with the shear keys in between the beams has been done. That's the top side. On the right hand is the underside where we did put a backer rod to finish off the look. Portions of the underside of these beams are visible to the public. You can go out and see that today. These are some of the post-tensioning rods that puts the beam together. Some of the precast decks. Here we are taking a look at any fine cracks that can be addressed while out in the precast plant. The top surface of the deck slab, even the surface prep can be done at the plant. Here it's scarified because it's anticipated to receive a topping slab. Again, great care to even protecting any exposed rebar is cementitiously coated to prevent rust while it's waiting in the stockpile. And there are some of those geometric details that I explained earlier about the little hammerhead and the boot-shaped finish, where you can eliminate the need for formwork to complete that closure form. Completed decks, ready and waiting at the precast yard. Some beams that would not as repeatable and fairly unique in its own right were built out of wood. And these are the node beams, and the way it was, the geometric curves and whatnot. You must respect the carpentry work on this formwork here. All the curves and shapes and stuff. Rebars in that node forms. That styrofoam block out on the far right side there, those are for the post-tensioning areas. This is a mock-up of the node area. All the 4 nodes make up this the structure here. Okay, so as far as the site goes, when the contractor shows up to site, it was staged such a way where one contractor would really, excavate, waterproof, even build the invert, and even build portions of the lower level walls. So the walls ended up being cast in place, but all the interior work still remains to be precast. Here you have the invert installed, the cast in place walls. Now it's ready for all your precast members to be installed, to be erected and installed. Here you have some of the cantilevering beams of the mezzanine level. We are at the lower level now, and only these beams these beams and the node beams were the only ones that's propped. All the other beams, again, the idea of selling it and having an immediate stage, all the other beams did not require any shoring, which really expedites, which really lends itself to what we call an accelerated construction. Here is the full span mezzanine level beams. This is the multi-beam that you saw earlier at the markup, now installed, post tensions. This image here shows how all the truck beds lining up, okay, and the crane is just ready to pick it up, place it, pick it up, place it, pick it up, place it. And so during design, this is what we envision as the assembly line approach. And here it is now in construction. The mezzanine decks have been installed. Now we're placing the deck slabs. You can see the deck slabs are now ready to be, have its closure for place. Again, with the immediate platform, working platform, you place these decks, you can work off of it. After the mezzanine level are installed, the mezzanine walls are cast, you now have yourself a pedestal for the upper level beams, which is what you see here. This is the first picture where, this is in the open area where you can stand on the invert and look all the way up to see both level beams. The node beams being installed, you saw this earlier in the markup, now it's being installed on site. These open areas, the contractor took advantage of that as their areas to be able to reach and install the upper level beams. The deck slabs around the node beams are being installed. This now makes the upper level slab. This is where the trains are now running on, the level the trains are running on. This view here is from the mezzanine level, overlooking that open area where you can actually see onto the lower levels. During design, we dubbed this the bridge area. Here we are from the invert level looking up at this open bridge area, and you can see the two levels of beams. Again, portions of the underside of these beams are exposed, and you can see that on the view on site today. And this goes back to the integrated architectural finish benefits of precast design. Even the smoke exhaust were precast, again, to lend itself towards accelerated construction. Unfortunately, you don't see this out on the site because it's covered with nice architectural finishes. On the lower right there, you can also see the platforms, precast platforms being installed. This is as much as the precast goes. I'm going to share a few photos of just all the other finishes and elements. These here are the steel elements for the elevator and the escalators. These are finishes for the escalators. The upper right photo there, that's the 45th Street node, where it's the only one that has 5 bays of escalators. 46, 47, 48 has 4 bays. But you can see this is the tiling and the architectural cladding being installed. Terrazzo finish, those are just concrete toppings that I mentioned earlier that goes on top of that scarified precast deck panels that I mentioned earlier. But even the prep work is part of the benefits of precast design. You can really see the station coming together now. Some of the finishes, the cladding, the metalworks around the smoke exhaust at the node area. You go there now, you look up, this is what you see. This here specifically is 45th. You can see by the wayfinding text over there. I'm going to share some before and after. Some of the before might be renderings or during construction. So during construction, as you saw a moment ago, this is what we call the bridge area overlooking onto the lower levels during construction and in this final state. There's a rendering of the upper level slab. and in its final state. This is a lower level. Again, I bridge you. We are now at the lower level looking up. You can see the spacious open area. You can see here portions of the underside of the mezzanine level beams and the upper level beams. That's not covered in the architecture cladding, exposed to public view. I just want to appreciate some of the architectural features that went into this project. All the archway openings at the civilization mimics a lot of the features of the historic icon of Grand Central Terminal today. At the node area, as part of the terrazzo floor finish, there are some of these wayfinder marks that if you look closely, you'll see 45th Street, 46th Street is shown. 46 and 47 is shown here. But this is this design here. You can see that every node at 45th and 48th also. This is the node in its finished state. In the lower right rendering there, you can kind of see that emblem, that 46th Street emblem. Okay. And this is at 47th actually. That concludes my portion of the presentation. I really want to emphasize my thanks to all the engineers of the design team. I had worked with many. I had the opportunity to work with many talented, supervisors and engineers that really should be here today. And I'm really just a messenger for their work. And I had the greatest opportunity. I can't thank them enough. I also want to thank MTA Construction Development for the opportunity for this historic history in the making project. Thank you.